We're now ready to take a look at how to evaluate direct effects. So we're going to look at the results from the analysis of the reduced version of the antisocial behavior example and introduce a calculator that will be useful. So slide 27 then, here are the 15 direct effects for the reduced model using the Model 10 version that we have settled on. So we have for the property item, we have direct effects that are significant from sex, black, divorce, age 94, for fight, sex, Hispanic, age 94, etc. down for the 7 items. So all of them have direct effects of some kind or another. On slide 28 then I showed the direct effects for the property and fight indicators, the first 2 indicators. So property on sex, black, divorce, if you go back one slide, sex, black, divorce, and age 94, and for fight for those 3 direct effects. So we see that property on sex, so that's a dummy variable for male versus female, is a significant positive effect. And for fight, we're going to focus on the same covariate, and notice that that has a slightly smaller direct effect for the fight indicator than for the property indicator. Still significant, however. Now, the effect on the probabilities, however, depend not only on these slopes in the U on X regression, so to speak, the latent class indicators regressed on the covariates, but also depends on the indicator's thresholds. So we're going to take a closer look at how that works. So slide 29 lays that out in terms of a probability curve. So we have a probability on the y-axis here, and that curve, the probability increases as a function of a logit. So we're working with logistic regression here for the indicators. So probability is equal to 1 over 1 plus e to the power of minus logit. So this familiar logit probability relationship, that formula is what's used to describe this curve here. And we're going to say that in this curve, it is much steeper at this point of the logit values. That is, a certain distance here between logits makes for a large difference in probabilities as compared to the same logit difference down here, lower on the curve with a lesser slope, making for a smaller difference in the probability. So I'm trying to say that the probability differences, for instance, between males and females, depend on where you are on the x-axis here. So let's take a look at that in some detail for a minute. So the logit here in this case is equal to minus tau subscript c, where tau sub c is a threshold for class C, and then you have beta times x. Beta is the direct effect of, say, males versus females. So that's the equation, and we're saying then that the small probability is obtained with a large threshold, and the probability up here is the probability of the indicator u being 1 as opposed to 0, and a small probability is obtained with the large thresholds. It's hard to exceed the threshold. They have a small probability of it exceeding the threshold, and a small probability, large threshold, small logits. So thresholds and logits are in opposite directions. That's why we have minus threshold here for the logit. Now the largest probability change from x equal to 0 to x equals 1 in this equation for the logit occurs at the steepest part of the curve with threshold close to 0, that is probability close to 0.5. Probability 0.5 is where you have the steepest part of the curve, and note that logit equals 0 gives probability 0.5 by this formula here. E to the power of minus 0 is e to the power of 0, which is 1. So in the denominator we have 1 plus 1. So the probability is 1 divided by 2, 0.5. Okay, so those are the basics here. Now let's take a look at the example where we do direct effect probability calculations for the property of fight indicators. We're going to compare males and females for the fight and threat class, which is the first class. And the Model 10 estimates are as follows. For the property indicator, we have a threshold of 1.352, a high threshold, meaning that it's less likely for people to admit to that indicator or that activity. And the direct effect is 0.676, which gives you a logit of minus 0.68 when all the other x's are 0. And the x's are largely binary x's, so setting them at 0 is a reasonable value. Now for the fight indicator, the threshold is smaller, and we have a higher likelihood in general to have people admit to that. The direct effect, however, is smaller. So that gives you a logit of 0.37 when other x's are 0. So this logit is smaller, or closer to 0 rather, than that, which means that the curve is closer to 0.5, where you have the steepest part. Now, probabilities for females versus males at 0 values for all other covariates except H94. Let's consider that. H94 is the only continuous variable, so setting it at 0 is not necessarily relevant, although it is in the range of H94. But setting it at its sample mean instead, you get these values for females, property 0.161 versus male 0.274. So males are more likely to engage in that, whatever that indicator measures. And the difference is 0.113 between those two values. For the fight indicator, females have the probability 368 and males have a probability of 0.511, and the difference is a little bit bigger. So even though the slope is larger for property than for fight, the difference in probabilities is larger for fight than property. That's the point I wanted to make. So that's what I've spelled out in the last bullet here. Which you have now read, I hope, and it concludes with the direct effect slope size alone does not tell the whole story about how important the direct effect is in terms of the probabilities. So now let's focus on this calculator that I mentioned, and that is a new feature in Mplus version 9. The Mplus calculator existed for latent transition analysis, and here we expanded it to calculating direct effects and also actually direct effect probabilities, and also actually with class varying effects we also compute odds ratios. So anyway, computing direct effect probabilities conveniently can be done by pulling down the Mplus menu here in the output and clicking on calculator, and then you get this window, conditional probabilities for the latent class indicators or conditional probabilities for the latent class variable as a function of covariates. So we click OK for the conditional probabilities for the indicators, and here's what we get when we set it for male equal 1. So I go back and forth here between sex equal 1 or male equals 1, but same thing. So what you do here then is you click on the covariate, and then you click on assign value, and then you put in the value, 1 in this case, and then click apply, and then you click on OK. And out comes this result. Male 1, black, Hispanic, single, divorced, dropout, all 0, but the remaining covariate H94 is set at its sample mean. So the conditional probabilities then are given for the different indicators. We're focusing on the first two here. And the columns then are the latent classes, and we're focusing on class 1, the fight threat class. And we're interested in the highest probability, the highest category of property, which would be corresponding to u equals 1 versus, as opposed to u equals 0. So we're looking at 0.274, and for fright we're looking at 0.511, which is what we saw on slide 30, if we go back to that. 274 and 511 is what we calculated at the sample mean of age 94. Going back to slide 34 then, we can go on to slide 35, where we do the same thing for male equals 0. So you have male equals 0 here. And then you get the value 0.161 and 0.368, which is also the same as what we have on slide 30 in the middle for females. Now we have a convenience feature in the calculator shown here on slide 36, where you can copy sets of values for covariates. So this is convenient when you compare, for instance, sex equals 0 to sex equal 1. You don't have to type in the other covariate values again, but you can save them. And it's also convenient if you change only a few covariate values. So you enter your values for the first set, click on the button above the OK, cancel, apply, copy values to new set. That will copy all the values you just entered to a new set. And then if you look at the top of the display, you see a second default tab will open to the right of the original default tab with the copied values that you can then edit, changing, for instance, the sex from 1 to 0. And you can even change the label of that tab. And then you click OK, and probabilities for both sets will be shown, one below the other. Now, the calculations that are done behind the scenes in the calculator can be done also using model constraints. So if you do direct effect probability calculations for the property indicator, for instance, comparing male equals 0 versus 1 and all other x's equals 0 except age 94 sample mean, then you do it this way. So you have the model here, C on the axis, and the indicators on the covariates, so U on the axis here. And what you do is you label what you're interested in. You're interested in the property on male, you're interested in age 94's influence as well, and since you're dealing with a property indicator, you want to also have its threshold in the first class here, which we're interested in. So we label that by T1. So these B's are the betas in that equation that I talked about earlier, and this T is the threshold. And then in model constraint, you compute logits and probabilities with the suffix 01 corresponding to male 01. Sample mean of age 94 turns out to be 2.957. So you have then, let's take a look at a logit for male equal 1. That's equal to minus the threshold, as we shown in the formula earlier, plus the coefficient B1 for male, times 1, which is the male dummy variable value, plus B2, the coefficient for age 94, times its mean value. So for sex equals, or male equals 0, we don't have B1 because B1 times 0 is 0. So then we have those logits, and the corresponding probabilities are then the ones plugging the logits into the exponential function here with a negative sign. And out come the values that we saw earlier on slide 30.